In this video, what we're going to look at is solving quadratic inequalities by using graphs. So your essential question would be, how do I solve quadratic inequalities by using graphs? So let's take a look. Here we have a table down at the bottom here that shows you the steps that you will take, and you see that that has 3 steps. If you look at the top up here, you see that these are the 4 possibilities of inequalities that you will have. You'll have y less than, y greater than, y less than or equal, or y greater than or equal. And then we break this down into 3 steps. So let's take a look at our steps. Step 1, you're going to graph the parabola that defines the boundary. And graphing your parabola we had in last class, so you know how to graph it. Then step 2, important steps here. Step 2 is you're going to use a solid parabola for y less than equals and y greater than equal. And then you will use a dashed parabola for y's less than and y's greater than. So 2 very important steps there. Solid parabola you associate with the equal sign, and dashed parabola when the equal sign is not present. And then our 3rd step here, we shade above the parabola for y's greater than or greater than or equal, and then we shade below the parabola for y's less than or equal or less than. So here are steps 2 and 3 break down how you will do the actual shading. Okay, let's take a look at an example. So we're going to start with y greater than or equal to x squared minus 7x plus 10. And we're going to go through those steps. So step 1, you know that you would actually graph this. So you would use your axis of symmetry, you would use your y-intercept, and you would use your vertex. So here's an example of it already graphed for us. We can see here that we have our vertex, we have our y-intercept, and so here's our vertex right about here. So I'm going to put in that axis of symmetry. Here is the y-intercept, and that gets mirrored over here. And then they chose to find the x-intercepts for their 3rd points, that being here at 2 and 5. So you can pick a point that you want that's close to your axis of symmetry. Now we're going to move on to step 2, and that means how do I do this? Do I do this as a dashed or as a solid? Dashed or solid? You can see that they did a solid. Do you know why? We do a solid because the presence of that equal sign. And then that leads us to step 3. So this was our step 2. And then step 3 would be the shading. So again, for our shading, we look at our symbol. So our symbol, again, if we look at that, that symbol is a greater than or equal, and that means we will shade above our parabola. That means we'll shade above our parabola. So we'll take a look at the next slide and we'll see how it has been shaded in. And there it is. So our step 2, so that is that shading. Whoops. Let's scoot back here. Now, the way that we are going to verify that we have shaded correctly is that we are going to do what we call test a point. So I look to see where I have shaded, and I'm going to pick this point right here. I'm going to pick this point 4, 0. Now, I'm going to sub this back in to our inequality. So we're going to sub into the inequality. Now, since this is in my shaded region, I must end up with a true inequality after I do my subbing in. So let's take a look at that. So here's my 4, 0 that I'm going to test, that I'm going to put in there. So remember X is my input, Y is my output. So I would have to have for Y, my output, and then my 4 as my input. Okay. And then we will simplify that down. And when we do that, we get 0 greater than our 4 squared of 16 minus our 7 times 4 of negative 28 plus 10. And then we end up with 0 greater than or equal to a negative 2. You see here they have a check mark. Why is that check marked? Because this is a true statement. Therefore, we can conclude that 4, 0 is in the solution set. Therefore, we can conclude that our shading was correct. So we will always do a test point to make sure we have done our graph correctly. Okay, now we're going to take a look at a second example. Now what we have is we have y less than negative 3x squared minus 6x minus a 7. So step 1, we are going to graph that. So let's see what that looks like after we graph it. Well, not that. So we come over, we find our axis of symmetry, we find our vertex, and we find a point. Now, those are the steps that you did for your homework. So we graph the boundary. Now notice that their boundary is dashed. Can you tell me why? Why did they dash it? We go back to that symbol of less than. That symbol of less than does not have the equal sign. So that means this becomes a dashed curve, okay? Now, our next step then is the shading. So again, we look at that. So let's write here, this is dashed. So we got that. Now we're going to look at it again for our shading. It is less than. Less than, remember, we shade below. So if I'm looking at my parabola and I shade below the boundary parabola, below, that means I will end up shading under it. So I would shade in there. So let's take a look at that. So that would look like this right here. So here's the shading below. And then the next thing we have to do is we have to do a test point. So I'm going to choose a point here. I'm going to choose this point right here, which is negative 2, negative 10. So since I picked a point that's in my shaded area, when I sub this in to my inequality, I must get a true inequality. So let's take a look. So here we're going to verify. We're going to try that negative 2, negative 10. So our negative 10 gets put in for our y value. Oops, hold on. Negative 10, that gets put in for our y value. And then the negative 2, of course, gets put in for the x. We simplify that through. We have one more step to go here. Negative 10 less than negative 7. So is that an actual true statement? Yes. So we have verified that we have done our shading correctly. So now what you're going to do is you're going to try some practice problems. Make sure that you have all of your notes handy. Make sure that you wrote down the steps, and make sure that you paid attention to when we do what? When we do a dashed or solid boundary, and when we shade above the parabola, or when we shade below. All right? When you're done, you will continue with your assigned practice problems.